o'clock, so let's get started. So, welcome to CSE 294, Algorithmic Problem Solving. So, just a quick thing. Who cannot be here Tuesday, Wednesday, Thursday for 40 minutes after class? So what I want to do is I want to only have class for 3 days a week instead of 5 days, because 3 to 4 for 5 days a week, I know none of you want to be here 5 days a week. I certainly don't. So who cannot do that?
So you mean like an hour and 45 minutes 3 days a week?
Yeah.
No.
Just as one continuous block. So anyone can't do that? You can't do that?
Yeah, I mean, I could probably work something out.
Okay.
Actually, yeah.
So if one person can't, then I can't do it. So I just want to make sure. Okay. So everyone good with Tuesday, Wednesday, Thursday, 3 to 4:40? I'll make an announcement, obviously. Okay. Any questions on that? Okay. Yeah. Let's see. Oh, nope. Wrong one. Yep, that one. All right, welcome. So what is this class about? It's mainly about problem solving and trying to come up with interesting algorithms that solve problems more quickly than what you would consider probably like a brute force algorithm. Try to think in a more clever way to solve a particular problem. All right, so it's the process of formulating and understanding problems, trying to understand useful data structures so that maybe this data structure solves the problem in a more asymptotically faster way, or is easier to work with, or uses less memory, a whole bunch of things that you can measure data structure and algorithm analysis with. So it's just really just trying to understand how algorithms work and how you can make some algorithms faster, how can you compare two algorithms, how, when you're given a particular problem, how do you solve that problem, what is your initial thought process behind that. So that's basically what this course is trying to prepare you to do. So you'll learn several paradigms. And just an algorithmic understanding, what algorithms do people really use in the world? Do people really use bubble sort or selection sort in the real world? And it turns out, no, there are better sorts for that. Do people store, I'll try to think of an example. How do people store items in databases? Do they just use a sorted list for a particular entry? Well, what if I wanted to sort for a different entry? Do I need to resort for that particular entry? And so it's just, what algorithms do people really use? What types of problems do people actually come up with instead of the problems that you've probably seen before? Make this application that processes user input and gives some output. What are the problems that people actually work with in the real world? And hopefully we'll get to the point where we talk about problems where we don't know if there's an efficient algorithm to do it. We know how to do it, but we don't know if there's an efficient algorithm to do it. So hopefully we can get to that point, because that's actually quite interesting. So about me, this was me, several of you have seen this before, but this is me when I did my Barrett thesis a little over a year ago now. So just to let you know, I'm a PhD student here at ASU in computer science. So I got my bachelor's here. This is the second class I've taught. Some of you were in my first class. So what I'm studying mainly are how to minimize the number of software and hardware tests for large-scale systems. So instead of trying every single possibility for a particular system, how can we minimize that number and do it in an efficient way? And that turns out to be a very non-trivial problem. Another one I'm looking at is network reliability. So given a network of computers, how do you construct links between the computers so that the network is as reliable as possible if some particular edge fails or a link fails between two computers? So how do you maintain whether a network stays connected, basically? So this is the second offering of the class. The first one was ended just a few weeks ago. So hopefully Since this is the second offering, there are probably going to be a few bumps in the road, so hopefully I'll try to minimize that as much as possible. So just administrative things, you need CSE 205 with C or better, because this is going to be a very intensive programming class. I dropped the requirement for this. For the project, as I'll talk about in a minute, you may need MAT 243, but you don't necessarily need it. So I do not, it's just a recommended thing. And if you don't know that, class is about discrete mathematics, trying to prove things by induction, doing proofs in general, just general things about math, basically. There's no textbook for the class, so yay, no more things you need to buy. I know the class is extremely overpriced, but there's no textbook for the class. There are plenty of online materials that I have linked to, and I will link a few more that you can use, such as like Python help for a bunch of exercises and things like that. Attendance is not required, but I highly recommend it because there's this one-on-one communication, and the class isn't that big, so there's more one-on-one help that I can give you in person, which can be quite useful. So for grade appeals, I say 1 week for once you get the graded item back. And I'll cover this in the syllabus, but it's just grade appeals 1 week. If you have anything to do with the disability services, please let me know as soon as possible so that I can give you the appropriate accommodations. Academic integrity, I'll emphasize this over and over again on the assignments, but make sure that your work is your own work. No copying and pasting of any kind whatsoever, because I've graded close to 1,500 students at this point, so I can really tell when someone has copied and pasted something, so make sure that it is your own work, make sure no one else can steal your work, that kind of thing. So class structure. So this is what I plan to do for the class. I might not get to because of maybe some scheduling things, or maybe we didn't get through everything, or maybe we got to more things, which might be awesome. But this is what I plan to do. So intro to Python programming. So the reason we're doing Python programming here is because the emphasis of the class is obviously problem solving and algorithms. So I want to get most of the boilerplate of programming out of the way, so we can focus on the thing that actually needs to be focused on, which is the algorithm design. So Python is an extremely easy to learn language, and there's a lot of things that you can do a lot easier, so that's why we're using Python. So I'm going to go over Python, obviously, but that's what we're going to use for the class. So intro to algorithm design, how do you design algorithms, what are the basic structures of algorithms, that kind of thing. So backtracking and constraint satisfaction, so what that is basically, instead of trying every possibility for a particular input, what we can do is we can structure it in such a way that we only do it in a certain number of cases. So we do it in a more algorithmic way instead of trying every possible solution, because that might not be possible in general. Divide and conquer, so what that is given an input, split it up into some partitions, so like maybe split it into half, like for merge sort. So you split the array into 2 pieces, recursively call on those 2 pieces, and then merge the results back. So that's basically what divide and conquer is, divide the input up and merge the results back. Graph algorithms, so I'd argue that graphs are the most important thing to understand in computer science, partly because of all the applications that they have in social networks and network design, obviously. So we'll be covering a lot of things about graphs and how to model a particular problem as a graph. Dynamic programming, so what that is basically storing previous computations so you don't have to recompute something. Okay? So that's basically what dynamic programming is. Optimization, so maybe we don't know how to get the exact optimal answer, but maybe we can try to optimize as much as possible in a short amount of time. So that's what optimization is about. And NP completeness, so that is about the stuff about algorithms that we don't know an efficient way to do. So hopefully we'll get to that, but I don't know yet. And presentations for the project portion of the class, I don't know if we'll get to that, but hopefully we will. So that's the structure of the class. So what do I expect from you? So the workload of the class, the biggest thing of the class is programming assignments, because you need to be able to code up some solution to an algorithm, write pseudocode to an algorithm, all that stuff. So that's basically the largest portion of the class, so mainly programming. I may ask some written stuff, but mostly programming. So the idea is trying to apply algorithms that we've seen before to new and interesting problems that you haven't seen before. Okay? I have due dates on the schedule, so I'll be updating those as necessary. Roughly, although this isn't quite correct, but what I'm trying to do is have every assignment be 6 days, so that the last 2 weeks you'll have extensive amount of time to work on your project, basically. So I believe we'll have 8 assignments, so 7 of them will be programming and 1 of them will be a scribe assignment I'll explain in a few days. Okay? Cool. So a midterm, I'm definitely going to have, if I'm going to have a midterm, I'm going to make it take home for a week, and as well as a final for 20%, which is also take home for a week. Okay? I may decide to not have a midterm or final, just make the programming and the project worth more, but as it stands right now, we're going to have a midterm about in the middle for 1 week, and then a final at the very end for 1 week. Okay? And so the part that I'm most excited about is the project. So what I want from this class is we're going to, as we've seen from the schedule, we're going to cover a ton of different algorithm design patterns, but we're going to only cover them a little bit. We're going to do basically a breadth of all the basically well-known algorithm design patterns. But the project is basically to allow you to pick, but maybe I like this algorithm. And what I want you to do is to go very far deep into that algorithm, such as what has been done on this algorithm within the last 10 years or so in research. Try to look at the papers. What has been done there? Are there some other optimizations we can do the algorithm that we haven't covered? A bunch of different interesting things. So that's what we'll be doing. So you'll look at a particular problem, see what else in the field has been done. You'll choose from a list of topics, or you can present to me a project topic. So hopefully I can get, I'm still working on the list of projects, but hopefully I'll get that out to you by next week. Okay? You can either, so it's basically, there are a lot of things you can do here. You can have an entirely implementation-based project. So you basically code the entire thing, or you can have an entirely theoretical project. That's totally fine too. Or a literature survey where you look at a bunch of papers about a particular algorithm and see this algorithm performs better for this reason, this one performs better for this reason, etc. So at the end, you'll have a report plus possible implementation, and you'll have some milestone things where you tell me how your project's been going at this point, what else do you need to do during the semester. And so hopefully we'll have a presentation at the end. And yes, you can do it individually, or you can have a group. I'm gonna limit the group size to 3, so we don't have a huge group. Because if you have a huge group size, then I'm gonna expect you to do a lot more anyway. So I'm gonna limit you to a group of size 3, but you can do it individually or group of size 2 if you want. All right. So are there any questions about any of that? Yeah.
Is this still the class that replaces L3? Is that still happening?
I'm still trying to get approval from the department. There are 2 294 classes. The one that's logic for computer science currently does, but this one isn't currently yet, but I'm going to try to get the department to do that.
Okay, cool.
Yeah. Any other questions? Okay, so I'm just going to go over the syllabus. So this is just the course description, basically what I've just said the entire time. Major topics, same thing. Tips for success, so obviously this covers everything basically, but the general idea is come to class, be prepared, watch the lecture videos because I am recording these if you had some struggle. Post on the Google group, so all of you should have gotten an announcement from me about a Google group for the class, and there is a link in the first assignment where you can ask questions on the Google group if you're struggling with a particular thing. Something like, hey, I tried to run Python, but it gave me this weird error. Does anyone see it? Does anyone see why I'm getting this error, kind of thing? Okay? Yeah. And then trivia, so course website, all of you should have seen the Blackboard site by now. That's just telling you to go to the Blackboard site. There's no textbook for the class. These are just helpful links to help you get started with Python if you haven't coded in Python. How many of you have coded in Python? Okay, so this will be quite helpful to a lot of you because Python is widely used in academia as well as in industry. So learning Python will certainly be helpful, but certainly in this class we'll be using Python, so these links might help you with that. Attendance, I don't take attendance, but we're all adults. Come here if you want to, or don't. But if you come here, it'll be a lot more beneficial because of this interaction. Email, just follow basic email etiquette. I have more detail there, but yeah. Assessment, so basically what I just said on the slides. Assignments are 40%, the project's 30%, midterms 10%, finals 20%. Okay. And the grade distribution's here, you can see it in the syllabus. Grade appeals within a week, and the protocol for how appeals work is here. Schedule is here, so what I'm planning to do is hopefully I can cover the Python stuff within 2 days, so we can get the Python stuff out of the way, we can get to the more fun stuff, all the algorithm stuff, which I think is really interesting. So algorithm design, the constraint stuff, all that stuff is here. And an important dates is just basically mirroring what the schedule says, except it's just telling you when things are due, when the withdrawal date is, all that stuff. Okay. Yeah.
So I assume that's going to change or be reworked since you're only doing Tuesdays and Thursday and
yeah, I'll change this. Yeah, absolutely. Yeah. Disability, yeah, make sure to tell me if you need disability accommodations. Academic integrity, as I've said, is your own work. Everything is individual, and you can't cite anything on the internet unless I explicitly allow you to. Okay? Just basic academic integrity. Ethical behavior, just don't harass each other, basically. So, yeah. Title IX is self-explanatory, and university policy is also self-explanatory. Okay. So, any questions about the syllabus at all? Okay. So let's look at your first assignment. So, shoot. All right. So this is your first assignment. So hopefully some of you have already seen this. So these due dates will change based on when I complete the Python stuff. So whenever I complete the Python stuff, it'll be due 6 days after that. So I'll change this as necessary. So the basic idea of this assignment is to get practice with Python so that everything in the class, in the rest of the class for programming becomes a lot easier. So contents, it explains everything that's on Blackboard. Preliminaries just tells you, rewatch the lecture videos on Python programming, as we'll get to. Learn Python the hard way. So what that is basically a whole bunch of tutorials on Python, everything that basically you'll ever need in Python. So I highly recommend doing that. And if you get stuck on some part of the assignment, please ask a question on the Google group. Okay? Obviously, if you have a personal question, please send an email to me. But if you have a question about anything else, just post on the Google group so everyone else can see. Okay? So let's talk about the grading of the assignment. So the assignment's worth 10 points. So the first point is sign up for the mailing list. You get a whole point, just sign up for the mailing list. Wow. All right. Second point is actually also really easy. So since this is a very diverse group of students in this class, because there are so many sophomores, juniors, and seniors, I don't know what the background is for everyone. It's not quite as focused as for another class. So I just want you to tell me, what is your background, what things you know, what things are you not comfortable with, especially the stuff with 205 background. So especially the stuff about recursion, Vigo, and binary trees, because those are the algorithmic stuff. So I just want to know, do you know some things from 205 about algorithmic stuff? Okay? Cool. So just fill that out, easy point. So I originally had this assignment be 3 programming parts, but I decided that's a little too much. So the first part of the assignment is you're going to choose from a possible 2 projects, assignments, where you'll just pick one of these and then code it out. So the first option is, how many of you have ever worked in security? Okay, yeah. So let's just say that we're hackers, right? And we want to get access to Bill Gates' email or something. Bill Gates, bill.gates at Microsoft.com or something. So we certainly know the email, right? But we don't know the password. So how would you try to find the password? Well, one thing you can do is just look at all the passwords of length 1, all the passwords of length 2, and test each one at a time, right? And if any of them succeed, then we got the password, obviously. But the problem is that how many passwords could there be? Well, think about it. Let's just say that it's only letters. So there's only 26 letters. So all the passwords of length 1, there are 26. All the passwords of length 2, that's 26 times 26. Then passwords of length 3, 26 times 26 times 26. It gets to be pretty large, right? So what people have done is they've made a list of passwords that are the most common. So, like, obviously the top one might be password, like PASSWORD, right? And then they have a list of the most common passwords. So you can look at a whole bunch of these files on the internet, especially on GitHub. And actually some of the test cases here are some of those most common passwords. And if you're a competent web developer, obviously you're not going to have password requirements, because password requirements actually don't mean anything. But some websites, like Stack Overflow currently, do have password requirements. So the requirements there are the passwords at least 8 characters in length, 8 unique characters, and has 3 of lowercase, uppercase, numbers, and a special character, right? So your password must pass this test in order to be a valid password for Stack Overflow. So what I want you to do is, given this text file of a whole bunch of passwords, print the ones from the file that do match this specification, right? Because there's some that don't fit, right? And print each of those to the screen. Because why would you want to do that? Well, by filtering out the ones that won't work, I don't need to test those because they can't be valid passwords for Stack Overflow anyway, right? So basically you're doing a giant filter over the list of passwords that you're given. Okay? And this describes the formatting. I have test cases on here. a sample test cases and a Python file that will test your file against the test cases and tell you how many points you got out of the total possible, which is 4. Okay. So, and let me know if there's a problem with that. So grading, so it's just the number of matched passwords in the file. Okay. And the test case will help you determine how many you've gotten so far. So the second option here is for security also, when you send, you don't send your plain password over the internet because people can intercept that, or actually really anything over the internet plain. So what you do is you send a ciphertext over the internet, right? But that ciphertext has the same distribution of letters within that text. So one thing you can do as a ciphertext is increase each of the letters by 1. So A becomes B, B becomes C, C becomes D, Z becomes A, right? So what you can do is you can look at the distribution of letters, right? So like as this example, the Oxford Dictionary has, say, A has 8.167% of the characters that are letters in the input are A, right? So what I want you to do is, given a file which has a string in it, determine this frequency, right? So you'll say maybe A has 0% and B has 35% or something. So that's basically what this part is about. Trying to determine the letter frequency of a string in a given file. And there's more specification here, but that's the basic idea. Formatting is the same thing, how the file's going to be run. Grading is just the number of correct test cases. Okay? Cool. Any questions about those two parts? Okay. So now to the part that I actually really like doing. So you've always been told in past classes to add comments, to structure your file in a good way with tabs and indents and all that stuff, make it look really nice. But there are some domains where there's a very, very, very limited amount of memory, right? And it's very difficult to have part of a program on disk and part of a program in memory. It's easier to just have the entire program in memory, right? So what I want you to do is try to minimize your Python file, the given Python file, such that it has the exact same functionality, right? So that it can fit within the smallest amount of memory possible, okay? So I can actually show you the file itself. It's on Blackboard. So it's just a simple file that has a main method, and what it does, it handles inputs, does some sorting, elimination of duplicates, some methods in here. And so what I want you to do is, I want you to minimize this file as much as possible, to minimize the number of bytes in the file so that it will perform the exact same functionality. Yeah, so what I actually have on the site is, if we go to assignments, we can look at these minimization cutoffs. So, I'll just explain it here. So I have some ground rules, just obviously make sure it's your own assignment, but I exclude some certain libraries that you can use, but there are some libraries that you can use. Everything's explained here, how grading works. So the idea here is there's a certain number of bytes that is given in the file, and in the Python file, and there's a cutoff for what I say is, yeah, you did 100% on this part, right? And so that's the preliminary cutoff. Then I have 2 more cutoffs which I count for extra credit. So the secondary cutoff, you'll get an extra point, and I have a further cutoff which is even lower, which I call the Instructor Cutoff, which is basically the lowest that I've gotten so far. If you can get lower than this, then you'll get a lot of extra credit. Okay? So here, if you look on the site, I have the original file is almost 2,000 bytes. The first cutoff. So this is If you get to 675, you got 100% on this part. Okay? But if you get more than that, you get more credit. And I have my current best right here. Okay? So, are there any questions about the assignment? Not at all? Okay. So let's get to the Python stuff.
Actually, I have a question.
Yeah.
Did you say pick one of
Yes.
those three?
Yeah. No, not one of the three. Actually, I'll just get it here. So,
I thought it said pick two.
yeah, so you choose one between the password one and the letter frequencies one. You choose one of those two, and
then
the second one is the minimization. And obviously, if you do both of the choosing part, I will grade the first one. Okay, so you can't get more credit, obviously. So just pick one and do the minimization one. So mailing list 1 point, background 1 point, one of those two problems 4 points, and minimization is 4 points. I think that's 10 points. Okay, and the way grading in general will work is. So I don't know how many points there are going to be in the semesters. Obviously, I'm trying to have 8 assignments, so hopefully I can have each assignment be worth the same. So it'll be a total of 80 points in total, and that'll be worth 40% of your grade. Okay? Any questions about that? Okay. Let's get to Python. So let's see. So what we're going to basically cover here in these slides are about introduction to the Python programming language. Try to understand what are the main things that you'll need for programming in this class, what things are most common in the software industry with regard to Python, all that stuff. So I have some like documentation links, a tutorial, actually the official tutorial, and a bunch of other links that may prove useful here. Because I actually look up the documentation all the time. So be familiar with the documentation of Python so that you can say, oh, what are some of the methods for lists or for sets or any of that stuff. Okay? Cool. So I got a question earlier about which version of Python, because there are actually 2 versions of Python currently you can download on the official site. And the one that we'll use is Python 3 because it's the wave of the future. Everyone's trying to convert to it. Most of the libraries now are supporting it, so we'll use Python 3. So because it's consistent, there aren't weird rules with some functions. It's basically much more consistent. Way of the future, as I said, and there are actually only small differences between Python 2 and 3. So that's why we're using Python 3. And the reason we use Python 3, obviously, is so that you can test your programs much easier. There won't be compatibility problems, so it's just to make it standard. Okay. Python 3, what's new? So basically, your to-do tonight is to install Python 3 on your system. So what you do is you go to the site and to the official Python 3 site, download the installer and install it. And then what you do is you'll test if Python 3 is working on your system, basically. Okay? So you can either use your computer, just download it onto your machine, and try to install it and then run it via the terminal or command prompt or something like that. Then another way you can do it is if you're having trouble installing on your system, you can use Ubuntu, which is with a virtual machine. So how many of you have used a virtual machine? Okay, cool. So if you know how to use a virtual machine, then you can use Ubuntu because Ubuntu, if I'm correct, has Python 3 already installed when you install Ubuntu. So everything will be set up there fine. But another thing you can do is, since Python is an interpreted language, what you can do is you can use an online interpreter like, you can go to the site ide1.com. and what's here is it's basically a site where you can run pretty much any language you want. So what I can do is I can choose Python 3, and then I can add code here as necessary, like print hello world. So I can push run. And as I said, Python is an interpreted language, so there's no compilation done. Well, actually, there is a little bit of compilation, but it's mostly interpreted, right? So here there's no input, and it outputted hello world. So it's basic. Another good reason to use Python is that it's basically very extremely readable, right? You can read out all of the things in the code as if they were English, right? It's extremely easy to read. So like, instead of just calling something like system.out.print, just call print and pass in the string that you want, and it will do exactly what you want. There's very little boilerplate when it comes to Python, as we'll see in a second. Yeah. So covered this. So the interpreter. So Python is an interpreted language, but it's also dynamically typed. So what does dynamically typed mean? It's basically, it won't, since it's obviously not compiled, it'll just run, and if something happens, it'll throw an exception. If something bad happens, right? It won't catch it early on, unless it's a syntactical thing. But in terms of what the semantics of the program are, it'll evaluate it at runtime instead of at compilation time, right? So instead of like getting an error like your string returned a function, your function returned a string, but you assigned it to an integer variable, and it won't catch that until you run it. And it's actually a very lazy language. It won't evaluate anything of the code until that exact line is executed. So it won't evaluate the program beforehand. It'll run it right when it's going to be run. Okay? So what does the compiler do? As you may have seen with Java, it translates a high-level language into some low-level language. And in the case of Java, it translates it to bytecode. And then the interpreter of Java runs that bytecode and translates it to machine code where it actually runs on the machine. Okay. So what Python does, it stores it internally, the structure of your program, and runs off of that internal bytecode, instead of saving it to another file and then you run it on that file. Because how many of you use Java with a terminal or command prompt? Okay, yeah, so you've seen something like this. So let's just try this. So public class, hello world. Obviously I'm coding in Java, static void main, string args, system.out.print, hello, and I'll save this desktop. So I have hello world right here. So for those of you who've done it, how do I compile this file? Java C, yes. So in the terminal, you call Java C on the file itself, and then it runs through the compilation step. Okay, so the ls command, if you don't know, just prints the list of the files that are in the directories that are at where you currently are in your current directory. So right now I have the assignment directory, but also the Java file and the class file. So how do I run this file now, after I just compiled it? Yeah, so now I call Java, which is the interpreter, not Java C, which is the compiler. So I call Java on which one, the class or the Java file? On the class file, because that's the bytecode file. Oh, actually you don't call it the dot class, it's implicit. So you just call the class file with Java, and then it runs it. Okay? But in Python, you don't do that. So if I want to say print, like we did before, print hello world, and the best part of Python, there are no semicolons. Well, actually there are, but they're not required. So let's just call this hello world.py. So the extension of Python is .py for Python. So now, if I want to run the file, I just call Python. Since we're using Python 3, it's not Python, it's Python 3. But if you wanted to use normal Python, it's just Python. But I'm going to call Python 3 here. And then the file name is hello-world.py, and it just runs. I don't need to do a compilation. I don't need to do saving it to another file for the bytecode. I don't need to run the bytecode. It just runs right off the source code, okay? Because it's an interpreted language and it's dynamic. Yeah.
Do you have to change to a certain directory that your program is in, or anything?
You have to run. You have to be in the directory that your program is in. Yeah. What you can do is you don't have to be in that directory. Like if I was one directory down. So obviously there's no hello world.py here, but I could run Python 3 ... /hello world.py. So what does the ... do? So what ... does is it looks one directory up. So the desktop directory had my hello world.py, and then there's a directory for assignment 1. I'm currently in assignment 1 directory. So what I'm doing is I'm looking up one directory and looking at the hello world.py, which is up here. So if I run that, it still runs. Okay. So as long as the path to the source code is findable, then you can still run it. So we did this. Python stores the code into internally with a bytecode format instead of saving it to another file like Java does. Then it's executed by a virtual machine, which is the Python interpreter here. So you invoke the interpreter with the Python 3 command as we just did. Okay. So we actually don't need a complete program, right? Well, a definition of program. But for unlike Java, we don't need to make a class. We don't need to make a method. We just write the things that we want. We write the function calls that we want. So there's not necessarily an enforced structure for Python. So that basically concludes that all Python files are just scripts, right? It just starts at the top and it just works its way down, right? Cool. So I can just call print hello world. It just prints, right? I don't need a certain structure. So print 2 plus 3, obviously it prints 5. So what does static mean for a programming language? Yeah.
It does things in compile time?
Yeah, it does everything in compile time, and dynamic does it at runtime, right? And so obviously Python doesn't have any compilation steps, so it's a dynamic programming language. And all type checks happen at runtime. So seeing if a function needs to do something with a string, but you pass it an int, it won't check it right at the start. It'll check it when you actually execute. Right? So we have variables, obviously, and assignments with numerical values that we can do. So like we set A to 1, B to 2, C to be the sum of A and B. And this is actually quite interesting. For print, you can pass a variable number of arguments to it, and it'll just print each one all in one line. So let's actually do that. So I'm actually not going to copy it because I want to show you that this is so easy to do that it's just very quick to just type up a script. Right? So let's say A equals 1, B equals 2, C equals A plus B. Print A, B, C. I'll ignore the type for a second. So if we save this on the desktop, so example1.py. And if we go back to our terminal, we can go back. So what does CD mean for change directory? Yeah, good. So ls, list everything. So Python 3, example1.py. And it prints what we expect. A is 1, B is 2, C is the sum. Okay? So that does everything we want. So what was that type thing? Although it doesn't really show here. So what was that? What do you think that type means without looking at the slides?
Guessing it's, well, actually, never mind,
So type is a built-in function. What do you think it does? Because note, I didn't write int a equals 1 or integer a equals 1, right? I just wrote variable equals value. So what do you think type does? It extracts the internal type of the object, of the variable. So what do you think type A is going to print here? Yeah, it's something like that, right? I didn't save it, so rerun. Right, so int, right? So that's basically what we expect. Cool. But we can also do strings. So we can print, say, hello world. And just letting you know, the standard is to have single quote strings. So there's no difference really between a single quote and a double quote. So what you usually are used to for like characters in Java, which have the single quote with one character, that's just a string now with one character in it. So everything's a string basically. So yeah, so if I print hello world, actually what I can do is I can set S to be hello world. And I want to do that type thing again. So type of S. So what do you think type S is going to print now? A class of something string related, right? And I need to save again. So it prints class of stir. So stir is a string in Python. Okay. You also have concatenation. So what if I wanted to print S with A after it? So the variable A after it, so the number 1. So how do I do that in Java? Plus, right? So you think, let's just try that. So S plus A. And this is actually going to throw an exception. Because the way Python works is that it checks the types at runtime. So if the types just don't work, it won't implicitly convert. So the way to do this is, so there are a bunch of built-in methods that convert from one to the other. So if I wanted to convert so if we look at the error, it says cannot convert int to stir implicitly. So what we want to do is convert int to stir explicitly, right? So what we can do is we can call stir of A, right? So what you think this does is it converts A to a string, or the number 1 to a string. So if we try that, it prints exactly what we want. Now let's look at this. So if I have the string which has a bunch of numbers in it, and I wanted to print the value of B, actually I'll just make this another name. If I wanted to print 2, actually integer plus, the lights went on. Yeah, it's worth it. So what I want to do is not concatenation here, but I want to actually do an addition of B and this string number. But it's a string, right? So obviously I need to convert it to an integer. So what do you think I need to do there? Instead of calling stir of now t, I call int of t. It just converts it to an integer. So b plus int of t. So what you think that does is it converts this, it tries to convert this to a number. If it succeeds, then it returns the actual number. And if not, then it'll throw an exception. So if we run this, it prints the sum because this ended with a 3, v was a 2, and it ends with a 5. So it actually does the addition correctly. Yeah.
So does it actually convert it, or is it kind of like
Yes.
Java? So
So
it's now an integer
Oh,
from now on? Or
no, it
it's like
creates a
casting?
new integer, returns the new thing. It doesn't modify the original.
Okay.
Yeah.
So you're like casting it?
Yeah,
in Java.
it is a cast, basically. Yeah. But it actually is a function here.
Okay.
So you're actually passing the thing in and returning something. So instead of a conversion. Yeah.
Okay.
Any questions on those examples? Okay. So we just did this. So actually another cool thing is the types of a variable once you make it aren't this. They can always change. So here, like I set a to 1 up here, but then I set a to a string. That's totally allowed because the type that's inherent to a variable isn't always the same. Okay? So that's actually really cool. You don't need to worry about the types all the time, right? With Java, if you have a wrong type, then it'll complain to you, then you need to go fix it. But here, you can actually modify what the type is based off what is being assigned to it. Okay? So program structure. So we have these statements that can just be executed one after another. Print A. So we have, I'm going to cover all of these later, but we have if statements, we have for loops, all that stuff. So how do you think the Python program can determine whether you're on the outer scope where like the a equals 10 is and where the inner scope is of the if statement? How did that work with Java? Well, you can either do brackets or the very first line of the if statement, right? But how do you think that does since brackets aren't required?
Indentation.
Indentation. So the way Python works is indentation. So it determines, so here I have 4 indentation spaces, but you can have any non-zero number. So if we do that, so let's do example 2. And I'll include all this code on Blackboard. So if you're frantically writing it down, don't worry about it. So a equals 10, print a. If a greater than 10, instead of call func, I'll call print bigger than 10 or something. So actually a really cool thing so I'm using Sublime Text to code this. So if you're using a nice text editor, what you can do is if you have some scope here, like that's going to be made for the if statement, once you make the if statement, push enter, and it'll automatically make the indentation for you. You don't need to type space, right? So here, the scope is 4 spaces in, or actually have here 1 tab. So you can either use tabs or spaces. It actually depends on what environment you're working with, but usually tabs work easier for me. So a comment inside the if statement. So let's see. So let's try to run this. So Python 3, example 2.py. So it did our print, but it didn't do this print inside because it's obviously not true because 10 is not greater than 10. So if I change this to 11 and then I rerun it, it's going to print obviously now 11 and then the print inside the if statement, which it does. Okay? So that's just the basic structure of Python programs. There's an indentation which determines scoping, right? And you can obviously have like if a times a is greater than 105 or something, then print another scope. So you can have scopes within scopes, just like in Java where you can have if statements within if statements, loops within other loops, things like that. Okay. Cool. So we can do this. So we have if and else, and obviously if else's for loops, while loops, they all end with a colon, which tells the interpreter, hey, the next line you should expect will be indented by some amount. It may be 1 space, maybe 10 spaces, maybe 4 spaces, but it's indented by some amount. Okay. We also have functions. So a function, instead of having like public, return type, name a method, it's just def. So def just means define a function. So if we go back to our example, I want to make a def test, print we are inside test. So again, since it has a semicolon at the end of it, it determines scoping. So the things that are inside the method test are indented. So if I want to call test, what should I do? Just call test, like that. So if we want to run this, it prints exactly what we want. Okay? It says we are inside test. Cool. We also have return types. So return 5. So if we want to say if we want to print the value of the test, what do you think will happen here? Well, it'll do the first print, and then it returns 5. So what am I going to print then at the end? 5. Yeah. So if I run this, it'll print 5. Okay. So we have if and else statements. I haven't covered loops yet, but we have functions, and we have returns of functions, obviously. Okay. One thing that makes a lot of Java developers really I would say jealous is that instead of Java where you can only return one thing, you can return more than one thing in Python. You can return any number of values that you want. So you can return 5, and so the way you do that is you separate it by commas. So return 2, 100. So if we print this, I think it'll work. Yeah. So it'll actually print everything that you return. So instead of just returning one thing, you can return a whole bunch of things if you want. And actually, this isn't like an array or a list. These are actually 3 separate things that are being returned at the same time. Isn't that cool? Another thing I really like is you can do simultaneous variable assignments. So instead of like having A equals 5, B equals 10, you can actually do them both at the same time with A comma B is equal to 5 comma 10. So what that does is it does a simultaneous assignment, matching the first thing on the right-hand side with the first on the left, the second thing with the second. So you can do a whole bunch of assignments all in one line, which I really like. Cool. So if we, yeah, so and what A and B are obviously clear. Okay. Any questions on that? All right, just a little more and then I'll let you go. All right, so we can have also functions within other functions and if statements within those functions. So we can call other methods within functions, obviously, and we can call the function itself. All right, so now we're going to start talking about some of the core language features, and the first one we're going to talk about are mutables. So obviously, mutable means you can change it after it's made. Right? That's what it means to be mutable. So I'm going to go into the syntax of this later, but just the things that are mutable are lists. So what lists are analogous to arrays in Java, but they're just called lists in Python. So if I want to make a list, I just say brackets with elements inside. And the good thing about lists is that they aren't type specific. So you can have integers and strings within the same list if you want to. Obviously, that's not good programming, but you can if you want to. Not type safe, as I just said. Byte array, although we won't use this, so it's just an array of bytes. So sets are actually really powerful here. So anyone know what a set is? So a set is basically like a list in a certain way, but a set has no duplicate elements. Okay? So what you do is, if you want to add something to a set, if it's already there, it doesn't do anything. But if it isn't there, it adds it. So it basically removes all duplicates. So it's just, and it's unordered. So there's no like indexing into that or anything like that, but they're unique and immutable. Not indexable, not hashable. I'll go over what hashable means soon. But the structure of that is curly brackets. So instead of square brackets for lists, we have curly brackets for sets. Okay? And I'll stop there. So are there any questions about anything we covered today? So just letting you know, we're going to now have the class on Tuesday, Wednesday, Thursday, 3 to 4:40. No class Monday, Fridays. Yeah.
Starting tomorrow.
Do you guys want to start tomorrow, or do you want to start next week?
Tomorrow.
I say so tomorrow.
Yeah, I'll start tomorrow. So starting tomorrow, Tuesday through Thursday, 3 to 4:40. No class Monday, Friday. So nice 4-day break. Not 4-day break. 4-day weekend. Okay. Any other questions?